Hi everyone, my name is Liang, and I'm managing the software team within StarFive Technology. It's my great pleasure to represent StarFive Technology to share and invite you to join us on our exciting journey in fueling RISC-V software ecosystem. As a start, let me walk you through the agenda plan for today. First, I will share about the software stacks and the software ecosystem that is supported by StarFive today, which we do it together with open source communities, partners, and vendors. This shall give everyone a good high level of understanding of what StarFive contribution and the area of focus. The next topic is architecture, where StarFive is seeing exciting challenges when enabling a particular new market segment for RISC-V. For this round, I will share more about software efforts and learnings on enabling SMP Linux to support heterogeneous RISC-V-based CPU cores. I will share about StarFive effort in enabling power management in Linux and our proposed implementation for RISC-V. The third area will be tools, where it's always StarFive goal to have best out-of-box experience for customer through proper tool solution. I will share our tools for the Dubé CPU core, which is StarFive in-house developed RISC-V 64-bit ultra-high performance core. Finally, I will share on StarFive effort in Linux distribution. We have picked up Dubé in-house and making it as the official Linux distribution for our VisionFive V2 board today. I'm also excited to share you on StarFive attempt to enable potential world-first Chrome OS for RISC-V. With that, let's get the fun begin. One of the top questions I got during engagement with customer is about the RISC-V software ecosystem. They are wondering if they can run the application when they move to RISC-V SA. Do they need to put a lot of effort to make it work on RISC-V? Hence, I would like to emphasize and echo what Mark said that no ISA is useful without a software ecosystem. Here are the software stack and software ecosystem that are being focused on by StarFive today. This covers end-to-end software solutions that are critical and integral to addressing various market segment needs today. Starting from bootloaders, StarFive have been supporting various bootloaders that are required for meeting each market segment needs. A good example is Coreboot, which is required for official Chrome OS. Next is hypervisor, where we have successfully run both Type 1 and Type 2 hypervisor on our Dubé core today. StarFive also maintains its own toolchain to ensure our customer can take the full advantage of high-performance StarFive CPU core. While for Linux build system, we support both Yocto and Buildroot in order to cater the needs from small embedded device to complex application. For operating system, StarFive is supporting various OS today, which are commonly used in various market segments, this including real-time OS. Finally, the middleware and framework have played important roles to ensure various applications can run on RISC-V seamlessly, even without significant modification needed. By now, you might sense it's a lot of software stack and component here. As a guy who worked in open source space for a long time, I'm a strong believer that open source software for open standard ISA is the perfect recipe in becoming world top ISA solution. Next, I will cover on the StarFive software development kit. For SDK, we cover both use cases, whether you are a bare metal developer or a Linux application developer. For bare metal SDK, it contains board support package, scripts, and software example, which allow you to get started your project in much shorter time. Next is toolchain. We have our optimized toolchain to our own CPU architecture. For toolchain, we support both Liang and GCC, and both toolchains supported both bare metal and Linux. Finally, Linux SDK is a Yocto base. It contains standard packages like Linux and bootloader. In fact, we also including eSDK. eSDK allow you to modify the code and generate the final packages within few minutes, instead of waiting few hours to get the full Yocto build. Last but not least, we also including QMU, which allow you to test your code before you deploy the final boot images on the target. Now, I will cover on the architecture front. If you remember last year, my colleague was sharing that we are trying to enable SMP Linux on the heterogeneous CPU core. You might wonder, what is heterogeneous CPU core? That means in the SoC, we have a high performance core paired with an energy efficient core.
both of them have a different microarchitecture. Today, we managed to run ES, or known as Energy Aware Scheduling, on the Linux that run on the QEMU. From there, we discover only minimal changes are needed to get it work on a RISC-V. Beyond that, we are wondering, can we enable heterogeneous core with a different extension? A good example is that performance core have a vector support, while the energy efficient core doesn't have. We found out that is a huge workload to enable that, especially when it comes to the software emulation. That's why we believe that a better solution of that is to leverage existing the RISC-V profiles and the platform specification. A good example is that within LSOC, we can use high performance core and energy efficient core from different vendors as long as they comply to the RVA22. Besides that, we are trying to enable RISC-V support for the frequency invariance for faster response. Next, I will cover on our effort for the power management. It's important to addressing power sensitive market segments. Today, I'm proud to share that we are almost complete to enable a complete Linux power management stack. In this part, we are covering two areas, which is the system-wide power management, and the second part will be a component-based power management. For the system-wide, user can either suspend or turn off the entire system. Once they do that, they can wake up the system through wake up sources such as USB or wake on LAN features. For the component-wise, user can do that against CPU or the devices. For CPU, user can either make certain CPUs go into either state or make it running much slower through the DVFS. For the device-wise, you can turn off the power for particular device we are not in use. The right diagram is our design today. It encompasses of three components: Linux, OpenSPI, and the system control processor firmware. OpenSPI is in there to ensure that some privileged action can be controlled. For the SCP, it was designed to ensure better abstraction to the operating system, where Linux will not need to be changed when we change the hardware of the particular platform. As of today, the patch are ready. We are going to send to the Linux maintainer for the RFC, where we will try to get feedback from everyone. Now we reach the third part of the presentation, which is the tools. Today, we have released StarFive Linux SDK, which is a Yocto base. It contains 1,000 plus standard packages, which are common for embedded application element. To our users, the application which work on the other ISA Yocto will work seamless on RISC-V. Besides that, StarFive Linux SDK also enable customer to choose their final boot image, either for QEMU, FPGA, or the real hardware itself. Beyond that, we also enable Yocto Extensible SDK, or known as ESDK. This eliminates the need to download large packages of Yocto. As such, customer will be able to compile the entire system in much shorter time frame with a just simple few steps. To ensure best out-of-box experience, we also released StarFive StarStudio IDE. It encompasses four major areas. First, development wizard, where users able to kickstart their Linux application project or bare metal project without the need to go through lengthy documentation. Second part will be the GUI-based StarFive debugger. It contains all the standard debugger features within IDE. Third part will be a quick test with QEMU, where users able to quick test their code by just a single click of button. This will ensure the code can be tested upfront. For the fourth part will be a flash programming, where we integrate OpenOCD into the StarFive StarStudio IDE, where user able to program a blank flash from the IDE itself. Now we are reaching the final part of the presentation, which is the Linux distribution. On the Linux distribution, StarFive have picked up Debian in-house and making it as the official Linux distribution for our VisionFive V2 board today. We have been sharing this demo to various customers and forums to prove that today's state of RISC-V ecosystem and the middleware health. As shown here, we are showcasing our Debian in four major areas. For productivity, we have showcased a working LibreOffice that's running today. On the multimedia, we are showing FFplay to demonstrate our hardware video decoder. On the website, we have a working Firefox, and we are working in progress to enable our GPU acceleration in the Firefox itself. And last but not least, on the gaming, where we can stress our GPU to showcase our GPU stability and performance. At this stage, we are still working to enhance the performance of this application, including the optimization of the middleware. Hence, we would like to invite you, once you receive the VisionFive V2 board, to join us on this exciting journey. As mentioned earlier, I'm excited to share with you on StarFive attempt to enable the potential world-first Chrome OS for RISC-V. For this stage, we successfully built 1,000 plus packages with RISC-V support using the standard documented build flow. Since it's a huge project, our strategy today is to have both Chrome OS and Chrome browser work first before integrating them together. As shown here, we managed to boot to Chrome OS splash screen before it errors out. It's expected since we already disabled Chrome browser packages per our strategy that I mentioned earlier. While for the browser, to ensure it can be upstream, we are building the Chrome browser using the standard cross-compile method. Today, we're able to launch the Chrome browser on our Debian, and we are working in progress to ensure complete features of the Chrome browser. On the diagram below is our journey of our software effort today. I'm excited to share that we are progressing well on the enablement for NWGS, which is the framework for the web-based desktop application. We have added RISC-V support, and we managed to run 3D sample application, which is based on WebGL. Our latest conformance test passing rate is around 80 plus, and we will start to upstream these patches once it's fully passing. In the meantime, you can find some other work in progress patches on our public GitHub.
Last but not least, I have the honor to share with you 3 exciting announcements from StarFive. First, VisionFive V2 is shipped. We already shipped first batch to customers and already working on the subsequent batch. Second, JH710 is production ready. JH710 reached mass production stage now and delivered to customers today. StarFive will continue to work with customers to complete its implementation in the field of virtual desktop infrastructure, single board computer, laptop, and industrial gateways. Third announcement from StarFive today is on our next generation SoC, known as JH8100. StarFive next generation SoC implements a heterogeneous symmetric multiprocessing SoC architecture with proprietary coherent network on chip, which is known as Starlink 1.0, that connects quad performance Dubé cores, dual efficient core known as Merak, and non-coherent packetized NOC, which connect embedded power management processor, graphics, video, and high-speed I/O. Stay tuned for more information as we will share more in upcoming forum. With that, we have reached the end of today's presentation. Do join us and reach out to us at our open source committee website, rvspace.org, or you can contact us using any emails below. Till then, thank you for your time and take care, everyone.